Hello everyone. So today we will discuss significant figure is significantly important. Directly, very few questions they will ask, but indirectly, in integer type, its knowledge would be checked in examination. So let's start significant figure. That here you can see that every measurement has some degree of uncertainty associated with it. So let's suppose this is one sample. This sample length we are measuring. So instrument 1 is measuring its length and is coming 10.1 centimeter. Instrument 2 is measuring is coming 10.12 centimeter. And instrument 3 is measuring and is coming 10.123. So instrument 3 is measuring in detail. So there is very less chance that it will be less accurate. Means from here onwards, if that any instrument or that any measurement having more number of significant figure, means there is very less probability or possibility that it having errors. Clear? So instrument 1 you can see it having least error is associated with it, but instrument 1 it having maximum error is associated with it. It is just for example that since this is measuring in detail, so it having least error, whereas this one is measuring in not relatively that accurate, so it having more uncertainty or error associated with it. Now, after this further moving and we will discuss rules for counting significant figures. So, 5 rule we will basically study. So, here you can see all non-zero digits are significant. Yes, all non-zero digits are significant. 3 and 6. 0 before 0 before first non-zero digit is not significant. So if 0 is coming first non-zero digits before that, means all those are not significant. Here also this is not significant. This is the whole part, and after decimal these all those are decimal parts. But here you can see first is 1 is here, that non-zero, before that all those are 0. So overall how many here significant figure? 2. Here how many significant figure? 3. All 0 between non-zero digits are significant. All 0 between non-zero digits. So you can see all in betweens are significant. All 0 between non-zero digits are significant. Next, 0 at last position in integer may be or may be not significant. Like here you can see 1 2 1 0. So though this can be considered as significant figure 3 also, including 0 it can be considered as 4 also. Similarly here also it having significant figure 5. If this 0 we are considering, then 4. If both 0 we are not considering, then 3. How we can represent this one in scientific notation? This is the scientific notation. X into y. X will be always in between 1 to 10 and y is 10 to the power y is not considering significant figure. So like here you can see 1.2100. So if I am considering here 0, so overall how many significant figures? 5. Here 1210. So including 0 how many significant figure? 4. And if I remove that 0, then it having how many significant figure? 3. If we'll multiply this all, if we'll multiply this one or either this one or either this one, you will get this same digit. No need to worry. Okay. Now further moving. All 0 in decimals, all 0 in decimals are significant except 0 before first non-zero digits. Like here you can see this is first non-zero digits. So before that all are not significant, but after that 0 is considered as significant. So total 4 significant. For counting objects, it will have infinite significant figure. Why? Because for counting You know that it will have a natural number only for counting, like pencil, 8 pencils, so it is 8 only. But for representing, we will write 8.0000. You know that this 0 at last may or may not be considered as significant figure. So here it having how much? If we'll include all 0, infinite significant. So more the significant numbers or digits, more the accuracy. So since it is countable object, so for countable objects we can write like this, and we can say that it having infinite significant figure. Like that in a starting only we discussed that 3 measurement. So let's suppose in this measurement having more that significant numbers, means this is having more accuracy, right? Similarly, that countable objects also, in that we will represent like this. So 0 may be considered as significant figure, so it having infinite significant figures. Now here you can see that pi. So pi having, already you know that infinite significant figure, 3.141516 and so forth. So it having infinite significant numbers. As I discussed you that any number also we can represent as a x into 10 to the power y, then only we can consider its significant figures. So here you can see this is x will be always in between 1 to 10, and 10 to the power y is not considered as significant figure. It will be 10 to the power 1, 10 to the power 2, or minus 1, minus 2, like that. So here you can see this number is given. So this number we will change into scientific notation, and then after we will tell how much it having significant numbers. So here it is 9.1. Even we can write 9.100 into 10 to the power 3. So it have 2 significant, 3 also, and it could be have 4 also. Here you can see this number is less than 1, but it should be x must be greater than, means greater than 1, less than 10. So here it is 9.1, means multiplied by 10 to the power 4 divided by 10 to the power 4. So it became 9.1 into 10 to the power minus 4. So this will be not considered as significant figure. So total how many significant figures? 2. Similarly, we can represent this one also, 10900. So at last this may be considered as significant or maybe not. So 5, 4, 3 after representing in scientific notation. Okay, next moving further, rounding off is very crucial. Like suppose for example you are taking petrol, 100 rupees petrol, so they are not giving 100 rupees petrol, they are giving 99.91236, like that. So remaining amounts you are not bothering. So similarly here also, in a rounding off, will rounding off in such a manner that number existence should not that vanish. Like suppose for example 500 rupees any object you are purchasing, but if we'll rounding off that 0 and 0 and you will give 5 rupees, it's very difficult to survive. So here you can see that rounding off means we will remove last uncertain digits, like here 10.1, 10.12, 10.123. Yes, you can round off and you can say it is 10. So for rounding off, we'll see here that last digit, if it is greater than, if last digit is less than 5, then remove it and there is no change in preceding number. Preceding number means this is the last digit and this is the preceding number. So if last digit is less than 5, then no need to change, you just remove last digit and this is the rounding off. If last digit is greater than 5, then you remove it and add 1 in it. So removing 6, adding 1 in preceding number, that is 123.46. And if last digit is 5, then add, if it is preceding number is 1, preceding number is odd, then add in that 1. And if preceding digit is even, then no need to add. No need to add. Just remove that last digit. So like here you can see 123.415. So here 5 is the last digit. And here you can see preceding number is odd. So we will add in that 1. So it will become 123.42. If preceding number is even, then no need to change just remove the last number. So it became 123.46. Clear? Now coming to addition, subtraction, multiplication and division of that significant numbers. So answer cannot have more significant figures in decimal place than least accurate number. Means what? When you are adding two or more than two significant figures, in that significant figure which is the least accurate, means which having least significant number, that much only significant number should be there in your answers also, means final result. So like here, after adding normal addition, you are getting 2.31. Here in least accurate, how much significant figures are there? 2. So here also it should have how many? 2. So after rounding off, this preceding digit is less than 5. So just remove. So it became 2.3, right? So it will have also two significant figures. So after rounding off, it is 2.3. Similarly here also 1.2, 1.23, 1.345. So again you add normally, and after that which one is the least accurate or least significant? So this, how many significant figure? 2. So answer also after rounding off, it should be 2. So let's suppose after adding you are getting 3.775. So 5 is the last digit, preceding is odd, so you add in that 1 and remove 5. So it became 3.78. After that again last digit is odd, so again you add 1 and remove last digit, so it became 3.8. Similarly in multiplication and division also, that you multiply whatever that number is given, and then after which one is the least, accordingly after rounding off by keeping that preceding digit or that last digit whether greater or less than 5, you can go on. So like here you can see this one, after multiplying you are getting this number, but here last, that least accurate, which one is having 2 significant, so we'll round off. So after rounding off, how much you will get? That here you can see that 551 into 21. So after rounding off, you will get here 551.2. Further, if we'll round off, it will become 551. Now we can represent this one in a significant figure. So significant figure, how we can represent? Like this, 5.5 into 10 to the power 2. So overall, how many significant figure it having? 2. Understood? So no need to worry. Like suppose here we multiplied after getting this result. Even you can change here only in scientific notation, since this is already there in scientific notation. You can change this one also in scientific notation, and after that you can round off and same answer you will get. Otherwise you can do normal here multiplication. You are getting this one number. After that you round off this decimal part. So 1 after 1 is less than 5. So it became this one. After that again rounding off. So it became this one. But again you know that this number we need to write in scientific notation. So after writing in scientific notation, you will get this one only, 5.5 into 10 to the power 2. Actually it's coming now 551. So it will be 5.5 into 10 to the power 2 is again 550. Means significant figure is 2 only. This we will not consider. Clear? Similarly, you can multiply this one also. In that, significant digits are how many? Least one having 2. Here how many? 4. Here how many? 5. So at last it should have 2 only. So let's suppose after here we change in a starting only, that in scientific notation. Understood? And then after here you can see 2 significant figures. And this is normal multiplication. So like suppose n1 is there, n2 is there. 10 to the power n1, 10 to the power n2. The multiplication means summation. This will be not considered in significant figure. Here n1 and n2, whichsoever having less significant digits, in answer also it should have less significant digits. Understood? Similarly in division also like that. After division, whatever result is coming, it should have that much only. significant digits as here n1 and n2, whichsoever having less significant digits. Clear? Next, after that, moving to accuracy. So accuracy and precisions are two very important here. Last topic. Accuracy is what? That is the agreement of the particular value to the true value of the result. Whereas precision refers to the closeness of, is not the accurate value, is just close to the accurate value. So that closeness of various measurement for the same quantity. So here you can see, suppose sample A, B and C is there. So here we are measuring, so that one instrument is measuring this one, another instrument by that we are measuring this one. So let's suppose one instrument by this reading is coming 0.94 and 0.95. But that sample which we are measuring, this is the first trial, this is second trial, and this is the third trial. But that sample length is 1 centimeter only. So here you can see this is not near to 1, but yes, this both numbers are close to each other. So it's called, this both measurements are precise because they are close to each other, but they are not near to or very accurate to true value, hence it is not accurate. Here you can see 0.95 and 1.05. So again here also 0.5 and here also 0.5 difference there. In between one difference is there, right? Means we can say they are neither precise nor close to each other, and nor they are very close or accurate with respect to true value. But here you can see this two number, they are close to each other also, and they are close to true value also, means it is precise and accurate. Okay, so we completed this topic. Practice some questions related to that, and mainly we will focus on that, all those our other parts. In that, whatever integer concepts are coming or integer questions are there, we will apply this concept. Okay, thank you very much.